In this session, we'll present our work titled Camera Settings as Tokens, Modeling Photography on Latent Diffusion Models. Our method can input given text prompt and camera settings to generate image following photography principle. Here is the result. Our method is also available across different camera settings. Text-to-image models lack of photography concepts. For instance, if we want to generate images with the corresponding prompt and camera settings with the Stable Diffusion 1.5 model. The current workaround is to add camera settings directly as input text prompt. Seems like the output result encompass certain degree of photography concept, right? However, if we try to control the camera settings and change the aperture from f1.4 to f16, the image should have a greater depth of field, meaning the background of the image should be lucid. As you can see, the output result of the modified aperture text prompt remained its background blurry. Now the question is, how do we fix it? Our contribution on the aspect consists of two major parts: the camera settings dataset with 20,000 samples and the camera settings as tokens model. The proposed camera settings 20K dataset compiles three existing image datasets: RAISE, DDPD, and PPR10K. We use the EXIF metadata from these raw images. These EXIF metadata are normalized to the camera setting of an 35mm film sensor format, also known as full-frame sensor format. We then use blip to caption the images. Utilizing the camera settings 20K dataset, it's time to teach the LDMs to follow the specified camera settings. We train the camera settings embedding networks to encode the given numerical camera settings into the text embedding space, while the original denoising text encoder remain frozen. We then concatenate these camera embeddings after the sequence of the text embeddings, treat them as one of the conditional tokens. Further, we use LoRa to fine-tune the denoising U-net, enables it to learn the cross-attention relation between the introduced camera settings embeddings and the target image. To demonstrate the effectiveness of our camera settings tokens, we visualize the cross-attention layer and compare with the results using deep and focus as input text prompts. In the comparison, our camera settings as tokens activates more attention on the entire image, especially on the focal length token and aperture token. Our method can fuse with existing LoRa's for customization, such as those from ControlNets. In this example, we utilize LoRa from Depth ControlNet to enable image control with depth condition. Here's more results. Thank you for listening.